Imagine standing at the edge of understanding, only for the universe to pull the ground out from under you again. NASA has just issued a fresh alert on Comet 3I Atlas, and once more, the cosmos has rewritten the script. Just when the data starts to settle, just when the equations begin to align, just when scientists allow themselves a moment to say, finally, we understand what this thing is doing, the universe leans in and whispers, not so fast. This object is unlike the comets we have cataloged for decades. It behaves like something alive, shifting, reshaping, transforming its behavior as though it refuses to be defined by the rules we've spent centuries learning. Most comets follow physics. This one challenges it. NASA's newest bulletin didn't focus on brightness anomalies, color variation, or changes in the coma, features that usually dominate comet news. This time, the warning cut straight to the heart of celestial mechanics. The anomaly wasn't cosmetic, it wasn't visual, it was orbital. During a single night, tracking stations around the world recorded a fresh batch of extremely precise measurements. The same telescopes, same procedures, same software they always use. Nothing changed, except the comet. When astronomers fed the new coordinates into the orbital models, the residuals, the differences between where the comet should be and where it actually appeared, behaved in a way no one expected. Residuals should be tiny, random, directionless. These were none of those things. They were aligned. They pointed in a clear, coherent direction. They spelled out one shocking truth. The comet had changed the direction of the non-gravitational force acting on it. Translated into plain language, 3I Atlas changed its own push. It shifted the direction of its self-propulsion. Most comets are ancient, fragile snowballs, a mixture of ice, dust, rock, and frozen gases. As they warm near the sun, jets of gas erupt outward. Newton's third law takes over. Gas shoots out one way, the comet recoils the opposite way. This is normal. We model it, we calculate it, we predict it. But Atlas wasn't behaving predictably. Until yesterday, the comet's non-gravitational thrust was known, stable, mapped, accounted for. Today, that thrust direction has rotated, not by a massive angle, but enough to break the models completely unless updated. The math refused to converge unless scientists accepted the new vector, which meant only one thing. The comet had fundamentally changed its internal outgassing behavior. Something inside the nucleus shifted. Pressure built. A vent moved. A fracture opened. Or the rotation state evolved. Whatever happened, it was real, measurable, undeniable. Here's where it gets even more fascinating. While the orbital mechanics team wrestled with equations, the imaging team completed an independent analysis. Multiple observatories combined multiple exposures to build extraordinarily high-contrast images of the comet's inner structure. They found the exact same thing the mathematicians found without ever speaking to them. Last week, the coma and jet were stable. Today, different orientation, different brightness concentration, different geometry. The primary jet, the comet's main engine, tilted toward a new direction. Secondary jets reshaped themselves. The entire inner coma migrated subtly but clearly. Even the tail, millions of kilometers long, took on a faint serpentine curve that wasn't there earlier. Two independent methods, same conclusion. The comet had rotated its outgassing structure. The force acting on it changed. The trajectory shifted. This is not coincidence. This is evolution happening in real time. To understand why, we need to understand what a comet's nucleus really is. It is not a solid rock, not a metallic asteroid, not a monolithic structure. It is a fragile, ancient relic, a porous mixture of water ice, carbon monoxide ice, carbon dioxide ice, methane ice, ammonia ice, organic compounds, silicate dust, and primordial rock fragments. Solar radiation slowly penetrates the nucleus, but unevenly. Some patches heat rapidly, others remain frozen. Some vents blow continuously, others lie dormant for millennia. Eventually, pressure builds beneath the surface, pressure that can crack a crust weak enough to crumble under its own weight. When a vent collapses or opens, the jet erupts like a geyser, and the comet jerks in the opposite direction. Atlas appears to be undergoing exactly that process, but in a far more chaotic and unpredictable way than any comet we've monitored in recent decades. Scientists now consider two leading explanations. A previously sealed fracture finally warmed to the point of sublimation. Pressure built. Crust failed. A violent jet erupted from a completely new region. If this new jet is powerful enough, it can overpower the older jets, tilting the total thrust vector into a new direction. This perfectly matches what the models show. Comets don't just move, they rotate. And outgassing doesn't just push, it torques. 3I Atlas might be precessing, wobbling, tumbling, slowly changing its rotation axis. If the spin axis shifts, all existing jets change direction too, even if their source vents stay in the same place. This also matches the math. The most likely scenario, a combination of both. New vents awakening, old vents shifting, rotation evolving, jets competing and reshaping the nucleus, a dynamic, unstable system. A comet experiencing internal stress that may eventually push it to its structural limit. Comets are fragile. They have almost no structural strength, weak gravitational binding, brittle crusts, hollow regions, voids filled with gas, ancient fractures. History shows what happens when the stresses build too far. Comet 73P Schwarzmann-Wachmann fractured into dozens of pieces. Comet C 2019 Y4 Atlas disintegrated entirely. Comet Ison vaporized near the Sun. We have seen this pattern before. Jets shift, rotation accelerates, stress builds, internal cracks grow, the nucleus fails. To be clear, NASA is not claiming 3I Atlas is about to break apart, but the subtext in their internal behavior is unmistakable. More telescope time allocated, higher observation cadence, expanded monitoring regions, cross-team collaboration, rapid update cycles. You don't escalate observation unless something fascinating and potentially consequential is unfolding. What makes 3I Atlas extraordinary is not merely its behavior, but its origin. This comet is interstellar, born around another star, forged under alien chemistry, assembled from unfamiliar ices and dust, darkened by radiation fields we've never measured.
shaped by temperatures our solar system has never experienced. Then, after billions of years drifting between stars, it intersected our sun's gravitational field. It warmed, it awakened, and now we are watching a relic of another planetary system experience sunlight for the first time in ages. We do not know its density, tensile strength, internal layering, volatile composition, rotation stability, or fracture structure. We are learning all of that from how it behaves under stress. And so far, its behavior screams one word: instability. Not danger, not threat, just change. Rapid, unpredictable, profound change in a fragile body that has been frozen since Earth existed.